Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about tangent ratios and direct variation. We are on the Common Core Math standard of the number system, and we're going to be working with right triangles and ratios today. Alright, our guiding statement question is we're going to use tangent ratios to find the slope of a line and work with direct variations of triangles as well. Alright, do these numbers mean anything to you? Anything special? Any idea? Probably pretty guaranteed that the monitor you're looking at or the screen you're looking at has a ratio of 16 by 9, 21 by 9, or 4 by 3. All right? Well, movie theaters are 21 feet by 9 feet wide. Typical like widescreen movies are 16 by 9. And then generic basic TVs or any sort of screen is a 4 by 3. 4 inches long, 3 inches high, or so forth, okay? Guaranteed that the screen you're looking at and watching this video on is one of those ratios. It's got those lengths, or it's similar to those lengths. All right, so let's talk about that. Numbers can vary directly with one another. So let's talk about looking at a specific screen size. No matter what screen you're looking at, it's going to vary directly either 4 to 3 or 16 by 9. If my screen is 5.75 inches tall and it has a ratio of 4 to 3, then it will be 7.67 inches wide because the width varies directly to the length. If you think about it, it's got a ratio of 4 to 3. It's 5 and 75 hundredths inches tall, and it's x inches wide. So I'm going to cross multiply, divide, and I would get 7.67 inches wide. All right. What if it was 12 inches wide? How tall would it be? Well, you cross multiply and divide. 12 times 3, 36, divided by 4 is 9, so it'd be 9 inches tall. Okay? They vary directly with one another. Well, if we're going to graph this data, we would notice a pattern. The data would vary directly, and therefore we call it a direct variation. All right? And this is what a direct variation is. We can write a relationship between it. It's going to look something like this. It's going to be a straight line. Okay, it's going to be a straight line like that, and we can write it such that it's y equals some number times x. K doesn't equal 0. It always goes through 0, 0. And it's going to be some number times x. Okay? It's going to be a straight line, either up and down or going down this way. Notice that these are not direct variations because this one's curved. This one is straight, but it doesn't go through 0, 0. And this one's just looking weird. Okay? That's a direct variation. As x goes up, y goes up. As x goes down, y goes down, so forth. Okay? So look at these charts, and do these measurements vary directly is what we're going to be looking at. Well, look at this first one. All right? This one goes up 1, up 3, another one up to 3. This one goes up 30, up 30, up 30. Well, how do I go from 1 to 30? What do I multiply by? How do I go from 2 to 60? What do I multiply by? And 3 to 90? Yeah, well, that one varies directly because you're just multiplying x by 30. What about this guy? How do I go from 60 to 100? 70 to 120, 80 to 140, 90 to 160? Is there a consistency there? Well, sometimes you need to go all the way back to 0. So if you take it back, you're going down 10 every time. If I go down 10, I keep going 60 times. I do it 6 times down to 0 from 60. I will not end up at 0, 0 like I did with this guy. It's got to be through 0, 0, okay? Same thing with this one. Does this one vary directly? Does it go through x is 0 and y is 0? No, it doesn't, okay? So that's the easiest hint there. All right, what about these equations? Why don't you plug away at these guys, see if they vary directly, see if they go through 0, 0. Are you taking some number, multiplying it by x and getting y? Or can you rearrange it such that it would look like that? Well, I'll give you the hint. Here are the hints if you're having trouble. Number 4, it doesn't because it doesn't go up by a factor of 2. It need to be multiplied by 2, not adding 2. 5, yeah, because as x goes up, y goes up. Again, 6, x is dependent upon y. And same thing with 7. As x increases, so does y. All right. Well, let's look at right triangles and talk about direct variation with right triangles. We've looked at sine and cosine in the past. Now we're going to look at tangent ratios. Tangent compares the legs of a triangle. And this is why we talk about it being a direct variation, because it compares the horizontal and the vertical together. So a tangent ratio is this. It's comparing the opposite leg. So if we're looking at angle E, it's comparing the opposite leg to the adjacent leg. It's the direct variation. It forms that straight line. So the tangent of x is going to be opposite over adjacent. That's our fraction we're going to set up. So the tangent of E is what? A over B, right? And the tangent of D is going to be B over A, okay? And then again, we don't usually look at the 90 degrees, but it's just not possible, okay? We don't do that. All right, so this is the handy phrase that a lot of you may have heard. It's soa katoa. Soa because its sine is the opposite of the hypotenuse. Ka because it's cosine adjacent hypotenuse. Toa, tangent, because it's opposite and adjacent. I would highly recommend that you commit this to memory, okay? It'll really help you when you're trying to figure out the specific lengths of a triangle. All right, sine opposite over hypotenuse. Remember that? Sine of x is the opposite over hypotenuse. Ka, cosine adjacent and over hypotenuse. Looks like this. And then a tangent, the one we're learning about today. It has nothing to do with the hypotenuse. It all has to do with the legs, both the opposite and the adjacent. All right, now it turns out that the slope of a line is the tangent ratio. If you think about it, angle E here, rise over run, is the opposite, so E compares 3 to 2. Rise over run. So the tangent of angle E is you take 3, put it over 2, bam, there's your slope, okay? So we're going to write now the ratios of this trigonometric function. We're going to look at a triangle here. We've got 8, 15, and 17. Tell me, would you, what is tangent of P? Tangent of angle P? What would be that ratio? What would be the number over what number? Again, it's the opposite over the adjacent, so you'd write it as the leg of the opposite of P to the leg of the adjacent of P. So it's 15 over 8, 1.875. All right. Now, to go backwards, if I started with 1.875, and on your calculator there's called the inverse tangent, where I put tan with a -1 up there, and then I put 1.875, it will tell me the actual angle. Okay, so the angle on that triangle is 62 degrees. So this angle is 62 degrees, just because I knew that it was a 1.875 ratio. So do this one, tangent of R. Tangent of R, leg opposite of R over the leg adjacent of R. All right, 8 over 15. So 0.533. Now you could also find the angle of that guy. Yeah, you could do the 180 minus 90 minus the 62 up there, but if you put in inverse tangent of 0.533, you'll get around 28 degrees. Isn't that cool? If you know the ratio, you can find the angle of that triangle. Well, remember the wheelchair ramp? They have a 4-degree incline. It begins at 366 inches from the bottom to the end of the ramp. And what's the distance of the ramp on top? Sine, cosine, or tangent? Well, what do we need? We're trying to find the height, right? So if we start with 4, we're going to do the opposite over the adjacent. Let's use tangent. We're learning about it, right? Might as well use it. Let's do it. And get the tangent of angle 4 over equals y over 366. So cross multiply. 366 times the tangent of 4 gives me about 25.5 inches. About 2 feet tall. Okay? Now, what's the length of the ramp? Well, using sine here. Okay, remember, don't forget about sine and cosine here. You got y over x. So what's x? Well, we know x is 25.6. We're going to divide the 2 there, and we're going to get 366.9. So it's about an inch longer on that ramp. All right. Well, that's how we use tangent ratios to find the slope and the direct variations of triangles there. Pretty cool, huh? That you can take these and relate it back to graphing, especially with slope. Well, this was Matt as we talked about tangent ratios from mathsmath.com. Check us out on Facebook at Solving Maths Problems, or on Twitter at Maths Math, and enjoy math and movies.